Hello guys, in this video we are going to discuss the solution of the problem flatten BST to sorted list. So let us look at the problem statement. The problem statement says that we are given a binary search tree with n nodes. Each node has a distinct value assigned to it. The goal is to flatten the tree such that the left child of each element points to nothing and the right child points to the next element in the sorted list of the BST. You must accomplish this without using any extra space except the recursive call which are allowed. So we have to use recursion, that is clear from the question, and apart from using recursion we are not allowed to use any extra space. So let us try to understand the problem statement with the help of an example. So let us take the example which is given to us. So for instance, in example 1, the tree which is given to us is something like this. So this is the binary tree which is given to us, and this binary tree we have to transform it into a flattened binary tree, or flattened binary tree. And the order in which this tree has to be shown or displayed is it is in a sorted order. So this is a binary search tree which is given to us, and if the binary search tree which is given to us, if we have to sort this or if we have to print the elements in the sorted order, so then we usually do a in order traversal for the binary tree. So few things which are clear from the question is, first we have to do in order traversal, and the second thing which is clear, which is asked from the question, is the left. So each node left should be null. So the left of each node we have to make it null. Left is equals to null. So if we traverse the tree in the binary order, so the first element which we'll get is 2. So 2, the left child has to be null, so there is nothing in the left. The right will be the next element which is 3. Similarly 3, the left will be null, and then the next element 4, and so on, right? So 5, 6, 7 and 8. Okay, so this is what we have to do. So that's about the problem statement, folks. Now let us see how we will be able to solve this problem. So in order to solve this problem, let's take the same example, which is this. Let us forget about the tree for now, but let us try to print the tree in its in order traversal or in the sorted order. So if we print the tree in the in order way, then the tree will be something like this. So the first node will be 2, then 3, then 4, then 5, 6, 7 and 8. Okay, so this will be the order in which the tree should be. And the second thing which we see, and if you see from this figure, then we see that the left of each of these nodes has to be null and the right of each of these nodes should point to the next element. Okay, so the first thing which we are going to do is, let us say that the left we will make it null. So this will be null, the left is null, right? So all these are represents left child and we are marking it as null, and the right child points to the next element. So this points to the next element, this next, right? So one way to look, or one way to sort of intuitively look for this solution is, let us say that this is my previous node. Okay, so somehow so what we will do is we will keep a track on the previous node. So let us say this is my previous node and this is my current node. Okay, so if this is my previous node and this is my current node, so what I need to do is that the previous node left child I have to make it to null. So this we can do it, and the previous child right node is my current node, isn't it? And once we have manipulated the left and right child of the previous node, we will go to the next element. So now what will happen is in the next iteration the current will be here, and we will keep updating our previous, and this we will make it our previous. So I hope the intuitive portion of the solution is clear by now, right? So what we are going to do is that we are going to maintain a previous node with us, and each time we are observing a node, what we are going to do is that we are going to adjust the left and right pointer of the previous node, and once we have updated the left and right pointer of the previous node, we will go ahead and update our previous node to the current node, and so on we will do it. Okay, so in order to do it, what we are going to do is, so let's take the same tree, and we know if we take the same tree, which is so if you take this same tree, then we know that the in order traversal for this tree would be something like, so it will start from 2, then it will have 3, 4, 5, 6, 7, and 8. Okay, so what we are going to do here is, we are going to have a previous node with us. Okay, previous node, and right now what this previous node, we will take a dummy node for this one, and the element of that previous node we will set it to -1, and the left and right child is none for this particular case, right? We'll start from here, and now this is the root, and we will do an inner order traversal. So essentially what we are going to do when we will be at this particular node, so we are doing an inner order traversal, and eventually we'll reach at this position. We'll reach at this position, so this will be our 2 will be our current node, right? This is our current node, and the previous node is this -1. Now let's perform the same manipulation which we have talked about, which is 2 -1 left, we will make it none, so this is my left, and this I make it none, and the right portion will point to the current, so the current is 2. So this becomes my, this is how the arrangement looks like. And then all the so far all the left and right child of the other nodes remains intact, but this is how it is. Now what we will do is that once we have manipulated the left and right child, so now the previous becomes this, right? So now the previous is this. All right, now once the previous is this, so the current will be what? After processing 2, the current will move to this position, so the current is here now. So once the current is here, so again let us do the same manipulation. So the left we will make it none, and the right we are going to make it as 3, right? Again, now we will go ahead and update our previous. So now the previous points to 3, same manipulation, this, and where will be our current? Well, the current is here, right? Remember, we are doing the in order traversal here, so the current will be adjusted accordingly, right, on the basis of in order traversal. So this is what we will be going to do, and let us just fill the tree here now. So now this will be 5, 6, 7, and 8. Okay, so this all we have adjusted it, so this becomes none, this becomes none. However, the last node, right, after processing 7, after processing the left and right child of 7, we will make previous equals to, so this, the previous will be 8. But since this is the last element of the node, the 8 will not be processed. So here if you see in this tree, fortunately 8 does not point to any of left or right. We will take one more example where this idea will be clear. So here it is okay that the left and right child points to none, so this is fine. So this is how after flattening the binary search tree, the binary search tree after flattening will look something like this. And once we have this tree, so see, now all we need is these elements, right? We have already flattened it, so all we need is this element. And let us say this node I am representing by, so initially it was represented by previous, and let us say we will have one pointer dummy which points to this element initially, and we will not go ahead and update dummy. So the dummy will point to this element, and all we have to do is return the right of dummy. Okay, so the right of dummy points to the first element of the flattened binary tree, and this is what we are going to return. Okay, let me take one more example in order to make one more concept clear. So let us say the tree is something like this. Okay, so the tree is 1, 2, I'm sorry, this is a binary search tree, so let's have the binary search tree. So let us say this is 3, this is 2, and this is 1. Okay, So let us say the tree looks something like this. Now let's begin with our previous or a dummy node, which is -1, and then on the basis of in order traversal, the current will be here. So now let's make the arrangement. So the current will be something like this, and this node, the left child, we will make it null. Okay. After that, this previous will come to this node, and it will be something like this, right? This again we have make it null. Now we have updated our previous. So the previous is here. So again we have updated. Now the current is here, right? So now the current is here. So this adjustment we did it. But for 3, right? So if you see for 3, we have not processed 3. So right now, what is the condition of 3? Well, 3 points to the left child of 3 points to 2. So its left will point to this, right? Now what we have to do is, remember, this is my previous, right? So this is my previous. So now this left points to over here. So what we are going to do is, we are going to break that connection, right? Since this is the last node, so we can safely say that previous dot left, and similarly in some cases previous dot right should be equals to none. Okay. In order to understand why previous dot right should be none, just take this example. For instance, let us say 1, 2, and 3. And if you work with this example with the similar logic, you will understand why we have to set previous dot right also equals to none. Okay. So let us combine the solution, or let us combine the concept which we have studied so far. So the first thing which we are going to do is in order traversal. Okay. The second thing is, we will have a dummy node or a previous node which will be -1, and for each node in the in order traversal, we are going to update our previous left and right children. So this is my previous, and this left and right we are going to update it, and then we are going to move to the next element by updating the previous also, right? So once I have processed on the previous, I am going to update my previous to the current element, and by doing so we will be able to make appropriate changes in the left and right node of the tree. And once we have done that, what we have to return is the right of dummy, right? So we need to return only these elements. So dummy right is something which we are going to return, and the other and the last thing which we need to understand is the last node, right? So this example, the last node manipulation was not done, so the last node manipulation we will do it, and this manipulation is simply what we will set the left and right node to none. So that's about the explanation, folks. Now let us see how we can code this. Okay, so let's so let us look at our code. So if this is a null tree, if it's an empty tree, or if it is a single node tree, then we are going to return root or none respectively. Otherwise, this is just for recursion limit, and then we will have a dummy node. Okay, and the dummy node, as I have mentioned it in my explanation, that it will be -1, and the dummy node also, our previous also points to a dummy node, and this previous is a sort of this variable which we have defined over here. Now once we have this previous and dummy with us, we are going to do perform an in order traversal of the tree. Now let us look at the in order traversal. So this is the in order traversal, this is left, then this is the root processing, and then the the right over here. Okay, so left we have done it, and in the processing part what we have done is, we are going to go ahead and manipulate the left and right node of the child. So the left has to be none, right? As given in the question, the left should always be none, so that is what we have done over here, and the right points to the current node, which is represented by root over here. Okay, and once we have done it, we have shifted our previous to the current node now, which is like this. And after doing this manipulation, we will go ahead and come to this point. So yeah, so we will be here. Now we have manipulated it. Now the last node left and right should be set to none, as we have seen through an example, and then what we need to return is dummy dot right. Okay, so that's about the code, folks. Now let us submit the solution. So our code got accepted. So that's from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I will try to address them. Thank you.